I'm Ryan Post. I'm a senior here and I work in Dr. Bloom's lab in the psych department. And what we've been looking at broadly over the past few years is stress and how it manifests in differences in anxiety. And one of the different clinical applications we've been looking into with this project specifically is non-suicidal self-injury, abbreviated NSSI. NSSI is a clinical manifestation in otherwise healthy adolescents in which they'll elicit self-injury without the intent of suicide, usually done as an automatic internal reinforcer or an external social reinforcer in response to environmental stressor. And so other labs have injected rats, the model we use, with stimulants such as pemolene and caffeine, elicit self-injury where the rat will gnaw at its paw, which on the surface looks very similar to human NSSI. We've decided to look more at the etiology of the disorder and how it develops with stress in early life and then measure at different time points throughout the rat's development. And so what we did for this particular project is we exposed half of our rats to trimethylthiazolene, TMT, in juvenility. And TMT is a synthetic fox odor. As the fox is a natural predator of the rat, it makes sense that it would be unconditionally afraid. And then in adolescence and in adulthood, we measured for both anxiety-like behavior and pain sensitivity. Anxiety-like behavior was measured on an elevated plus maze. It's an elevated table with 4 arms. 2 of them are closed, 2 are open. The idea being that rats that are anxious will spend much more of their time in the closed arms as they're afraid of the heights. Pain was measured on something called a plantar test, in which a hot, bright light was shown on the plantar surface of the rat's paw, and we measured how long it took the rat to withdraw its paw due to the heat. What we found is that in adolescence, the rats who were exposed to TMT in juvenility were significantly more anxious than the control rats, but there was no difference in pain sensitivity. We measured on the next day in adolescence, but this time in response to a trigger stressor or a secondary stressor. So we exposed all the rats to inescapable shock, a relatively stressful procedure, and then immediately measured anxiety and pain sensitivity. And we noticed that there was no longer a difference between groups, but that all rats were significantly more anxious and significantly more sensitive to pain, likely pointing to the perhaps overly potent nature of the secondary stressor. Finally, in adulthood, we measured anxiety-like behavior and pain sensitivity again, and we found an interesting and very different result from what we found in adolescence. We found a difference in pain sensitivity where the TMT-exposed rats had a much lower sensitivity to pain or a much higher tolerance to pain than the control rats did, and there was no difference in anxiety. So in conclusion, what we found is a delayed effect in analgesia, a decreased sensitivity to pain due to the stressor that wasn't manifest in adolescence but did manifest itself later in adulthood. And anxiety was more of an acute effect in that it only lasted in adolescence and it disappeared by the time of adulthood. So what this suggests is that maybe the stress that's administered during juvenility is interfering with the development of the brain. In particular, there are 2 areas of the brain that are still developing at this point in time that have to do with the pain pathways, the medial prefrontal cortex and the hypothalamic pituitary adrenal axis. Both of these are involved in pain and their development may have been stunted due to the stress. This isn't a direct application to NSSI, but will hopefully provide insight in the future as people study the differences in stress and how they manifest in NSSI later in life.